Okay, so completing the square is a process that we did first semester to solve quadratics. And the way you did completing the square is you started out with something like 2x squared minus 8x plus 2 equals 0, let's say. And the first thing that you did is you made it 1x squared. If it was not a 1 there, you had to make it a 1 in front of the x squared term. So you divide everything by 2. So that gives us x squared minus 4x plus 1 equals 0. The problem is this won't factor. And so what we do is we do completing the square. So the first thing, or the next thing that we do, is we get rid of the constant by moving it to the other side. Leave some space, equals negative 1. Now we have the stuff on the left side that will allow us to complete the square. We got rid of the negative 1 because, or the positive 1, excuse me, by making it a negative 1 on the other side, because that was the one, the number that was keeping us from having a perfect square. Now what we do is we look at this number right here, negative 4, the coefficient of x. And we go off to the side and we do half of negative 4. What is half of negative 4? Negative 2. What do we then do with that number? Square it, which gives us 4. And this number we then add to both sides. Because if I make the left side bigger by 4, then I have to also make the right side bigger by 4. What that then gave us was something on the left that factored into a perfect square. What did it factor into? X minus 2 times x minus 2. And what it factors into is not a mystery, guys. What did we get when we took half of our middle term coefficient? Negative 2, which is why it's x minus 2 squared. There's no accident. We're creating it that way, so it's always going to occur that way. So let's refresh your memory on one other quick one, and then we'll see how this applies to conic sections. Actually, let me do this. Sorry, do another page. What if we had x squared minus 5x plus 1 equals 0? Well, first of all, notice that it's already 1x squared, so we don't have to get rid of that. I do have to get rid of the 1, so I'm going to subtract it again. Move it on to the other side. Now, we have to do half of negative 5. So what is half of negative 5? Yeah, but don't do decimals, guys. You know better than that at this point. I've been telling you guys since September not to do decimals. Negative 5 over 2. What do we do with that number? Square it, which gives you what? Positive 25 over 4. Right? Negative 5 times negative 5 is positive 25. 2 times 2 is 4. So that's what gets added to both sides. Now this is going to factor into something squared. What's it going to factor into? Yeah, x minus 5 over 2 squared. Here you would get a common denominator, which would be 4 over 4, and so you would get 21 over 4. What we're really interested in at this point, guys, is how we make this into a perfect square. That's the key. We're now going to see how this comes into play with conic sections. Any questions on the basics of completing the square? Okay. So let's take a look at how this applies to conic sections. For example, let's take something that looks like 4x squared plus y squared minus 8x minus 8 equals 0. The first thing we want to do is we want to identify this conic section. What kind of conic section is this going to be? We've talked about this already. Even though we didn't talk about it in this form, the rules still work the same way. Is it a parabola? Is it an ellipse? Is it a circle? Is it a hyperbola? Nope. Not a circle. Which one is it, guys? Go through your list that I gave you. We've gone over the list twice now. What do you look for first? What about squared? Squared doesn't tell me anything. Yeah. Is it x or y or both? Both. So it's definitely not a what? It's definitely not a parabola. Very good. Okay. What's happening with the x squared and y squared? Are they being added or subtracted? Added. So what is it definitely not? Definitely not a hyperbola. So it's either a parabola or a circle. So what do we look at to see which it is? Coefficients. Are the coefficients the same or different? Different, which makes it a what? An ellipse. That's it, guys. It's not going to magically appear in your brain. You guys have to ask yourself the questions. I gave you a whole flowchart list as to how you guys decide what kind of shape it is. Okay? So we know this is going to have to be x squared over something plus y squared over something equals 1, basically, right? We know we're going to need the equals 1. What we need to do now is we need to start by getting all the x's together, get all the y's together, and move the constant to the other side. So I just rearranged this, grouping my x's next to each other, then my y's, although there's only one of them, and then our constant on the other side. Now we're going to complete the square. To complete the square on this, what do I have to do first? Divide by 4. But here's the problem, guys. If I divide by 4, it's going to put a 4 on the bottom there, and that could cause me trouble completing the square on the y's. So instead of dividing by 4, there's another way to do it. We're going to factor a 4 out of the x's. Not out of the y's. That's going to stay the way it was. We're just looking at the x's right now. When I factor a 4 out of here, what do I get left over? Good. Now, can I complete the square on the stuff inside? Yes. What do I take half of? Half of negative 2 gives us what? Negative 1. What do I do with negative 1? Square it, which is 1, and I add it to both sides. There's only one problem, guys. We just lost our equal sign. We don't realize it, but we did. Those two sides are no longer equal. Why not? No? Y squared's on the same side with the x's. Only have to add it to each side once. What did I add to the left side? We added 4 to the left side. Do you guys see that? Very good. We wrote plus 1, but what's on the outside of that same parentheses? A 4. So isn't that 1 going to get multiplied by that 4? Because this 4 is going to multiply with that 1, what should I have added to this side? Plus 4. Do you see it? When you factor something out and you complete the square, whatever you add to that side in the parentheses will get that number in the front distributed to it. You need to take that into account so that you add the correct number on the other side. Does that make sense to everybody? You've got to keep them balanced. If I make the left side bigger by 4, I have to make the right side bigger by 4. Now this factors into x minus 1 squared. I still have a 4 in front of it. I have a y squared, and I have a 12. This is now my equation. Does everybody see that? Do I need to complete the square on the y's? Or are they already being squared? It's already being squared, right? So now, all I have to do to get this into the proper form is what? What do I need on the right side for an ellipse? A 1. So I have to do what then? These cancel, and I get x minus 1 squared over 3 plus y squared over 12 equals 1. Could we now graph that ellipse? Yeah, what's the center of that ellipse? 1, 0. How far am I going to go each way in the x direction? About 3. Square root of 3, right? About 1.7. How far am I going to go each way in the y direction? Square root of 12, right, which is 3.4 or so. 3.3, 3.4, somewhere in there. Okay, so do you guys see that we could graph this now from this point? So we identified it as an ellipse, so we knew what equation we were looking for, what form we were looking for, and then we completed the square. Any questions about that? Mm-hmm. Mm-hmm. Well, we could have on this particular one, but in general, we don't want to do that because what if I had a y squared minus 2y? And then I divide that stuff by 8. Now I've got y squared over 8 minus y over 4. Now when I go to complete the square on the y's, I don't have y squared by itself. Right? I need y squared by itself. So now I'd have to multiply everything by 8. And it just, you end up going back and forth, which we want to avoid. So that's why we just factor it out so that we can keep each completing the square step kind of self-contained, just with the x's or just with the y's. Okay, we're going to see one right now where we have to do it with both. Let me show you guys another example. How about (4x squared minus y squared). Already, guys, what kind of shape is this? Hyperbola, right? You guys see it? X squared minus y squared is a hyperbola. Guaranteed. Takes 2 seconds, if that, to identify these. Okay, here we go. Sorry, I think that's supposed to be a minus 4. Yeah, minus 4 is the book example. Not that it matters. We can do it either way. So the first thing I'm going to do is group my x's together. 4x squared minus 16x. Group my y's together. Minus y squared minus 4y. And I'm going to add 4 to both sides to move it over. Is everybody with me there? I just grouped my x's. Notice I kept pluses or minuses with them. Group my y's, keeping pluses or minuses with them. Move the constant number to the other side. Now, to complete the square on the x's, what am I going to have to do first? Take out a 4, which leaves us what? Minus 4x. So, to complete the square on this, I now take half of negative 4, which is what? And then do what with it? Square it, which is 4. Now, if I add 4 here, what am I really adding to the left side? 16. So what do I have to add to this side? 16. Now I'm going to work with the y's. What can I factor out of here? What do I have to factor out? Negative 1. Have to take a negative 1 out, guys, because it has to be positive 1y squared. That leaves me y squared what? Good. Plus 4y. Negative 1 times y squared is negative y squared. Negative 1 times positive 4y is negative 4y. I factor the negative out, so now it's a plus. Now I'm going to take half of positive 4, which is positive 2. If I square that, what do I get? 4. So I'm going to add 4 here. What did I really do to the left side by adding 4 there? Made it smaller by 4. So what do we have to do to the other side? Make it smaller by 4. Whatever you end up doing to one side, you do to the other. By writing a plus 4 in that parentheses, because of the negative 1 on the outside, I really subtracted 4 from the left. I have to subtract 4 from the right. Now we can factor. The first one is going to factor into 4 times x minus 2 squared. The next one's going to factor into 1 times y plus 2 squared, and the right side becomes 16. I don't really need this one. But what do I have to have for a hyperbola equation? It has to be equal to 1, doesn't it? So what do? So that gives us, these cancel and gives you a 4. So x minus 2 squared over 4 minus y plus 2 squared over 16 equals 1. Could we now graph that? Yeah, what's the center? 2, negative 2. How far are we going to go each way in the x direction from 2, negative 2? 2 units. How far in the y direction? 4. Draw the box. Draw the diagonals. Which way is it going to open? X direction or y direction? X direction. Do you guys see how easy it is from there? So this is how you put them into the proper form so that we can find the vertex right away, is by completing the square, oftentimes not just once, but twice. Any questions about that? Okay. So let me get you guys going on the homework.